LangGraph state management mechanism leverages checkpointing through the in-memory saver to persist workflow state across invocations, using the entrypoint, decorator, and final primitive to separate return values from saved state. This pattern allows for explicit control over what data is returned to the caller versus what is stored for future executions. We're about to examine how a workflow function is decorated with a checkpointer, how the final primitive structures dual outputs, and how thread-specific configuration maintains state isolation between invocations. The code will demonstrate initializing the workflow with a memory-based checkpointer, processing input values while preserving intermediate results, and observing how subsequent calls access the persisted state through the previous parameter.
From typing import any. From LangGraph, checkpoint, memory import memory saver. From LangGraph, func import entrypoint. At entrypoint checkpointer equals in memory saver. Def my workflow. Number, int. Previous, any equals none. Entrypoint, final int. Previous or 0. Hash this will return the previous value to the caller, saving. Hash 2 asterisk number to the checkpoint, which will be used in the next invocation. Hash for the previous parameter. Return entrypoint, final value equals previous, save equals to number. Config, configurable, threaded, some thread. My workflow invoke 3, config hash 0 previous was none. My workflow invoke 1, config hash 6 previous was 3 asterisk 2 from the previous invocation.
This example demonstrates stateful workflow execution using LangGraph's checkpointing mechanism. The entrypoint decorator creates a workflow with an in-memory saver checkpointer, enabling state persistence across invocations. The workflow function takes a number, parameter, and an optional previous parameter that automatically receives the saved state from prior runs. The key mechanism here is the final primitive, which allows returning both a value to the caller and a separate value to be saved in the checkpoint. In this case, it returns the previous value or 0 if none to the caller while saving to number for the next invocation. This separation of concerns enables clean state management without mixing return values and persistence logic. This pattern is particularly useful for workflows that need to maintain context between runs, such as multi-step processes or conversations. The in-memory checkpointer is suitable for testing, but would be replaced with persistent storage in production. The approach cleanly separates the computation logic from state management, making the workflow easier to reason about and modify. Let's break it down.
From typing import any.
Imports the any type from Python's typing module, which serves as a type annotation to indicate that a variable can be of any type.
From LangGraph, checkpoint, memory import memory saver.
Imports the memory saver class from LangGraph, checkpoint, memory module, which provides in-memory checkpointing functionality for LangGraph workflows. This enables state persistence during testing without requiring external storage.
From LangGraph, func import entrypoint.
Imports the entrypoint decorator from LangGraph's func module, which is used to define the starting point of a LangGraph workflow.
At entrypoint checkpointer equals in memory saver.
Decorates a function as a LangGraph workflow entrypoint using an in-memory checkpointer. The in-memory saver instance is passed to the entrypoint decorator, configuring the workflow to persist its state in memory during execution. This enables the workflow to maintain state across runs without requiring external storage.
Def my workflow.
Defines a function named myWorkflow with an opening parenthesis, indicating the start of its parameter list. The function signature is incomplete in this segment, showing only the declaration line without any parameters or body. This establishes my workflow as a callable entity in the current scope, though its full interface and implementation aren't visible here.
Previous, any equals none.
Declares a parameter named previous with a default value of none and type annotation any. This parameter represents the previous return value for a given thread, which is only available when a checkpointer is provided in the LangGraph workflow. The any type annotation indicates it can accept values of any type.
Entrypoint.final int
specifies the return type annotation for a function or method as entrypoint. Final int, indicating it returns a final object from the entrypoint module that is parameterized with two integer types. This suggests the function will produce a final result in a LangGraph workflow with input and output types both being integers.
Previous or zero.
Assigns the value of previous to itself if it's truthy, otherwise assigns 0 to previous. This is a common Python idiom for providing a default value when the current value might be none or falsy. The result is that previous will always have a numeric value after this operation, either its original value if it was already set, or 0 if it was none or falsy.
Return entrypoint. Final value equals previous. Save equals to number.
Returns a final primitive from the entrypoint with two parameters. Value set to the previous return value, and save set to twice the value of number. This terminates the workflow execution while passing the specified values to the checkpointer for state persistence.
Configurable, threaded, some thread.
Creates a configuration dictionary with a nested, configurable key that contains a threaded set to the string value, some thread. This establishes a specific thread identifier for configurable components in the system.
My workflow invoke 3. Config #0 previous was none.
Invokes the myWorkflow graph with input value 3 and a configuration object config. The comment indicates this is the first invocation where the previous value was none, suggesting this is either the initial run or a fresh thread execution. The invoke method executes the workflow graph with the provided input and configuration parameters.
My workflow invoke 1. Config #6 previous was 3*2 from the previous invocation.
Invokes the myWorkflow graph with input value 1 and a configuration object config. The comment indicates this invocation follows a previous one that returned 6, which was 3.2, suggesting the workflow maintains state between calls when configured with a checkpointer. The invoke method executes the graph's logic with the provided input and configuration, producing an output that may depend on both the current input and any persisted state from prior invocations. The workflow demonstrates LangGraph's stateful execution pattern using checkpointing. The entrypoint decorator with in-memory saver enables state persistence across invocations, while the final primitive cleanly separates return values from saved state. The previous parameter automatically receives the saved state from prior runs, creating a seamless state transition between calls. The thread-specific configuration ensures state isolation, making this pattern suitable for multi-step processes or conversations. The key insight is how the final primitive's dual output structure, value, and save allows explicit control over what's returned to the caller versus what's persisted for future executions, maintaining clean separation of concerns between computation and state management.
The checkpointer hoards what the function discards, then gifts back what it never owned.